Hello and welcome to this session, which is all about managing Kubernetes in a hybrid cloud environment. My name is David Holder and I work here at SUSE as a field engineer. And in this session, we'll be going over three main topics. The first of which is provisioning Kubernetes clusters across different cloud providers, both on-prem and in the cloud. Secondly, to provide central authentication to these clusters. And then lastly, deploying applications to these clusters using our built-in continuous delivery framework. So to begin with, let's have a look at the number of ways in which Rancher can both import existing clusters and also create new clusters from scratch. So we can import existing clusters into Rancher, and we can do so one of two ways. We can either natively import them from their hosted cloud provider type, so the likes of EKS, AKS, and GKE, and then we can import any other generic cluster. The difference here being that if we import a cluster as its native type, so in this case EKS, AKS or GKE, Rancher will treat that cluster as if it created it and therefore have full lifecycle management, whereas any other cluster is just imported as a generic cluster. We can also create clusters from scratch. So we have similar options here for the cloud providers, so we can do all the heavy lifting in terms of creating these clusters by allowing Rancher to make the API calls to create a cluster on that cloud provider using their specific type and then wire it back to Rancher for centralized management. The second group of options is to provision a new cluster based on an IaaS, so infrastructure as a service. This can be both on-prem from the likes of vSphere or DigitalOcean virtual machines, Amazon EC2 instances, Azure VMs, etc. And what Rancher will do in this instance is it will do all the heavy lifting in terms of provisioning the virtual machines, get them connected up to a specific network, installing a Kubernetes distribution such as RKE2 or K3S, and then wire it back to Rancher for centralized management. And then lastly, we have custom clusters. So this is where, for example, we need to deploy either to bare metal or to virtual machines that we don't have access to the underlying infrastructure provider for. So just to quickly go over some of the various options we have, I'm going to pick on EC2 as an example. We can provide some credentials, and what Rancher will give us is the ability to define the anatomy of our cluster as the first option. So we have machine pools that govern, which virtual machines are going to be instantiated, where they're going to reside, and what their specification is going to be. So in this case, as it's a EC2 based cluster, it's instance type, so we have, for example, T3A, C, class, etc., to determine what virtual machines get provisioned. So we can obviously have multiple pools, which is what you'd want in production to separate out the roles. So we have etcd, control plane, and worker roles. We can separate those out across different machine pools as we see fit. Then when it comes to cluster options, we can select, as you would expect, the Kubernetes version, a CNI, and then tweak this cluster as we see fit. So we can modify some of the networking options, whether or not we want to pull images from a private registry, so a facilitator of air-gapped environments, as an example. And we can repeat this process for many cluster types. So this particular environment is only managing EC2-based instances, but you can imagine that a Rancher instance can manage clusters from a mixture of all of these cloud providers. So we have a central plane of management for these clusters, irrespective of where they reside. So a typical pain point our customers have, and generally Kubernetes administrators have, is how to secure access to these clusters. So imagine you have a variety of different clusters on different infrastructure providers or cloud environments. Each cloud environment may have its own way of managing identity and access control. So on-prem, you may have something like Active Directory. In AWS, you have your access and secret keys, and this may differ from different cloud providers. So how does Rancher address centralized authentication? Well, the first option is we can essentially hook Rancher up to an authentication source. And this particular environment is currently using GitHub as an authentication source. But if I just switch over to another environment where I haven't configured this, we can see the variety of options that we have. So what this will do is it will form a relationship between Rancher and subsequently your clusters and an authentication provider. So this can be, for example, classic on-prem AD or to something more exotic like Okta and Ping. And what we're able to do then is, by fully embracing the RBAC model, to provision or to govern who has access to what and what's the scope of their access. And this applies to all of our clusters. We can be extremely granular in how we want to control this. So as an example, if we go to roles, we can see 3 levels of roles within Rancher. We have global roles, which determine what can users and groups do within Rancher as a management platform. So can they create clusters, edit clusters, delete clusters, and perhaps change some of the Rancher settings. We then have cluster level roles. So what can users and groups do to specific clusters? So can they, for example, delete persistent volumes or create namespaces and any combination of those? And then lastly, we have projects and namespaces. So a namespace is a standard Kubernetes construct. It is effectively just a segmentation of your Kubernetes cluster. A project is something that we've created, and it's essentially an administrative wrapper around many namespaces. So you could group namespaces together inside an administrative unit we call a project and apply RBAC roles and resource options at that level. You can also create your own role. So say, for example, someone needs to have very granular control over what a certain particular user or piece of tooling needs to have to a cluster. So we can give this role a name, and then we can add in our different resource types. So this is just a wrapper around the native RBAC construct found inside Kubernetes. So we have our typical list of verbs, so for example gets, updates, deletes, and our resource type. So we can pick, for example, persistent volumes. So any member of this role that's attached to a cluster can only do certain things to certain resources, and we can add as many of these as we want, so we can go extremely granular in terms of how we allow access into our clusters. And this is reflected in the users and their kubeconfig files, for example. They will only have access to certain things that they've been given access to explicitly by the RBAC framework. So at this point we have our clusters deployed. We've implemented a centralized authentication and access control framework, but we haven't actually deployed any applications to these clusters. And there's a few ways we can do that within Rancher. So for those already familiar with Rancher will no doubt be familiar with the apps and marketplace feature. So this is basically just like a self-service portal for users to pick and choose which applications they want installed to the particular cluster that they're viewing. As good as this is, it doesn't scale particularly well. So say, for example, you need something like an agent or a workload or any kind of application on a vast number of clusters. And that's where our continuous delivery technology comes in. So continuous delivery is all about GitOps at scale. It's the ability to define how we want our applications manifested by placing artifacts in a Git repo. And we can use Rancher to orchestrate the deployment of those workloads to hundreds, potentially thousands of clusters. And the first thing I'm going to do is to apply a label to a select few of clusters. So this cluster view here is just a list of clusters that this Rancher instance is aware of. And you'll notice in the middle here, we have 3 clusters with fleet in the name. And those are the clusters that I want to target for a particular application. So the first thing I want to do is to add a label. And I'm just going to add owner and David H as the key value pair. And this becomes important because when we group clusters together, we can use these labels as the selection criteria. So that's the first cluster. I'm just going to make the changes to the other 2. So once we've labeled our clusters accordingly, we can now create a cluster group. And a cluster group, as you would imagine, is just a way of grouping clusters together via some form of commonality. And in this case, it's going to be a label pair. So if I give this cluster group a name, so David H cluster group, and I can add a specific selector. So by default, you can include all clusters that this Rancher instance is aware of, or you can specify a subset by using things like labels. So if I put in here, for example, owner and David H, we'll see that that specific criteria has matched 3 out of the 5 clusters that this Rancher instance is managing, which is exactly what I want. Lastly, I can then define a Git repo where my particular application or applications reside. So I have a very basic demo in my repo, so it just contains a YAML file. You can put in raw YAML files, Helm charts, or customize. You can even reference external Helm charts if you wish, but as a very basic demo, I just have a service and a deployment with a demo application. And this is what I want installed to all 3 of those clusters, but I don't want to go through and install it 3 times to repeat that process for every specific cluster. So what I'll do is I'll create a new Git repo. I'll give this a name. Put in the URL. I don't need to change anything else for this particular environment, but you can add additional authentication information should you need to. But the key bit here is to define where to deploy this application to. So I could still select individual clusters, but I don't particularly want to do that. I want to target the entire group, and that's what I'll select here. So what Rancher will do here, or continuous delivery, is kind of act like the middleman between your application that's defined in your Git repo and your clusters that are being managed. So if I create this, what we'll do is we'll observe what continuous delivery will do, which is to identify discrepancies between what's in that Git repo and what resides in those clusters. So if I select this Git repo and go to resources, we can see it's deploying that service and deployment object set for each particular cluster. So in this case, cluster 0, 1, and 2. And to access this application, I can simply put in a URL. And this is just a demo application that visualizes which backend pod is facilitating that particular HTTP request. So this is now running on all 3 of my clusters, but say for example I want to make a change. I can simply use GitOps mentality and tools to orchestrate that. So in my YAML file I can, for example, change the color that's behind the cow in these images here. So I'm going to change this from blue to green. Hit apply. So I've made a change in my Git repo. So what we should see is after a small amount of time, continuous delivery will identify that there is a discrepancy. So a new commit has been made, it's modified the application in some way, and it's going to reconcile those changes across all of my clusters, or where that application is deployed based on this group. So we can see here it's already identified that. It's beginning to update the resources. So in this case, it's updating the deployment because it's part of the spec. And then what we'll also see is if we switch back to our demo, we can see that the application has changed. So we've influenced how this application is configured and manifested by using GitOps as a key piece of technology.